going to start chapter 9, which is dragging and collisions. This is, it's a fun topic. If you've looked at the chapter, it's a big chapter. If you looked at the keynote, it's a big keynote. So I'm not going to rush through it. But that said, there are a few things in the keynote that I don't normally cover because I want to get to physics and the even more gamey aspect of coding in Solar 2D. This sort of starts us on that path. This will enable us to put stuff on screen and move stuff around on screen with our finger, which is kind of cool. And then also detect where the object is and whether it's hit a target or a location on screen or not, and respond or react to that in some way. So that said, don't be surprised if I hit a slide and skip over it. That's probably what's going on. All right, so it's interesting. In Solar 2D, touch is built in. Touch and tap are built in. We've done stuff with tap. We've done a lot of stuff with tap. There is a second touch listener called touch. And if you add the touch listener to an object, a display object, say, then Solar 2D will tell you when you are touching it. Touch has 3 different phases, unlike tap, which are began, moved, and ended. And you can make use of those phases in the touch handler to make something draggable around the screen. That said, kind of like with swipe, which we have talked about, it's not built in to Solar 2D. The touch is, but the ability to drag stuff around is not. You have to code that yourself in the touch handler, just like swipe. We coded the ability to detect whether the user had swiped up or swiped down in the touch handler, in the section of the touch handler where the user's finger is moving. So we're going to be building on that today to do something kind of even cooler. All right, so the idea of drag is that when the user puts their finger down on the device or on a display object which you've added touch listener to, then Solar 2D records that and also records that location of the user's finger. And as long as that their finger's down on screen, then the touch handler will be able to report on that XY location of the user's finger live as they move it. So conceptually, drag is actually kind of easy in that we'll just, as the user moves their finger, we'll assign the location for that object to the location of their finger, the XY location of their finger. So conceptually, just as they move their finger, we'll be coding it in that touch handler so that whatever that object is follows the finger. It's maybe 2 lines of code. This is what I would call simple dragging. If object 1 is the object we're dragging, and we have access to the event data in the touch handler using the variable event, which is how Drawn to Code writes it, then we can set the X and Y values of object 1 to the X and Y values of the event just with these 2 lines of code. And Lua's got this kind of nice little syntax where you can combine statements like that together just by putting commas in between them. So the issue is that it isn't a great solution. It does work, but if there's a gap between where the user puts their finger down, say on the display object, and the center of the display object, then when you first start to move it using whichever of these codes you want to use, the object will jump to the location of the finger, because that's what we're telling it to do. We're saying set the location of the object to the location of the finger. So if there's a gap between the center of the object and the location where the user starts the drag, you'll get this jump. And for small objects, it's not necessarily super noticeable, but for larger objects, it can be disconcerting that the entire object kind of shifts suddenly. And obviously, if you're coding a game and there are consequences to the user dragging the shape into something, they lose points or whatever, then having it jump, when they start to try to drag it would be really difficult. And I mainly go into detail on that because it matters when you're coding this by hand. If you're using Drawn to Code, I already provide this more advanced drag handling by default in the default touch handler. All right, so activity 1 was just a really quick follow along. We're going to add a shape to a draw to code stack, and then we're going to add the touch listener to it, and then we're going to drag it around screen. Okay, this is a super easy activity. So when doing this, for whatever reason, I don't know, I like polygons, and I use the star a lot or the arrow a lot or something kind of fancy. But that gives us a polygon display object right in the center of the display. Now obviously you can drag it around now because you're in draw to code, and you can drag it to relocate it in your design. That's not actually, dragging it live on screen. So let me save it. So I had set up a folder for today and stuff. So I'm in mobile designs. We have skipped ahead to chapter 9. So I'm going to create a chapter called chapter 9. And then I'll call this activity 1. Here's the running version of the Lua code generated by your design, and you can't do anything to the star. It's just a static display object that's sitting there. So let's add touch to it. I have object 1 selected. I'm going to add the listener here in the details settings panel for object 1, and I'm going to pick the defaults tap, but I'm going to pick touch. And then I'm going to just hit OK. And like all of the other listeners and widgets and stuff, Jonico will write everything necessary to make this work, and then also provide this default snippet of code. Before we glance at that, let's just save it and run it. And now I should be able to drag this around the display. So if you've got a touch screen, you should be able to drag it using the touch screen. If you have a mouse, you'll just click and drag the star around with the mouse. And if you have a touchpad, it just depends how you have it set up. But you'll have to tap and drag it as you would tap and drag anything else, on screen. One caution, just as a heads up, would be it is possible to drag it off screen, you'll notice, and you can drag it all the way off screen, and then you've lost it, right? Because there's no way to drag it back if you do that. It's lost in the Pixelverse or whatever. If this is stressful to you that the arrow's gone and where is the arrow and how will we get the arrow back, you can just refresh the Corona simulator and it'll get it back. Okay, so look at the snippet. Here's the default snippet for touch, and it's a big snippet. It's the biggest default snippet I write, I think, but it gives you basic information about the drag. It captures the start location of the drag, but also corrects for the gap between the center of the object and the center of the touch initially. And then for the moved phase, it updates the location of the target object, which I call T, to the event X and Y adjusted by that initial gap. And then when the user's finger is lifted from the device, it ends the drag and you're done. So I forgot to look, but let's do it again and look at the console because we should get some basic info. As you drag it, you should see this basic information about starting the drag and stopping the drag. You could also track the pixel location and print it out if you wanted to inside the moved phase here. Whatever information you think you need, you could certainly watch it. Okay, so depending on sort of your, anxiety level for the star, you might be wondering, well, how can I keep the star on screen then? This is distressing that I can drag stuff off screen and then never see it again. And certainly if you were designing a game, you probably would not want that to happen, right? For the most part, if the player is dragging some sort of game object around screen, then it needs to stay on screen so they can keep dragging it. To have it disappear completely would be kind of odd. So the next question, or the next topic is, well, essentially, okay, how would we do this then? How would we limit the range where something can be dragged. What if we have a playing area in which they can drag something, but we don't want them to be able to drag it out of that area? There are visually on screen, maybe there are boundaries, or maybe you're just limiting it to the very edges of the device screen. Or obviously you could combine. Once you learn how to do this, then you can limit the motion of dragging in whatever way that you care to. Now that you know if-then logic, I'm hoping this should be a piece of cake. I refer to this first example as a boundary box or a bounding box, but then I also sometimes refer to it as a fence because it does sort of look like a fence. So conceptually, what that screenshot there is showing is, what if we have our star or whatever your favorite display object was, and we want it to stay on screen. So to do that, we're going to erect this red fence around it, this red bounding box or boundary box. And that will limit where I can drag the star to. The only thing that's slightly confusing here is that the way I'm coding it, it's based on the center of the star, because that's how everything works in Solar 2D, is via the center of the display object. And even the touch, obviously when your finger touches the display, Solar 2D figures out where the center of that touch is, and the center of the touch makes it the XY value of the touch. In any event, if I want to stop something from going off screen, I have to pay attention to where the center of the shape is being dragged. So that red box will actually let half of the star go across it, which will, if I've calculated the location of the red box there correctly, will stop say if we drag it to the left, it'll stop the left edge of the star from getting off the left edge of the display, or the top, or the bottom, or the right. So I don't put the bounding box at the edge of the display. I put it at the edges of the display, but inset for half of the width and half of the height of whatever the display object is. This may make more sense when we do it and you can actually drag it around and see it, but that's the basic idea. So you might wonder then, how do we get that boundary box? And it's a bit of math. But it is something also that certainly this basic idea that you don't want the user to be able to drag something off of the device screen is kind of common, to lots of games. So I've coded in a function in Draw in a Code called getBoundaryBox, and it's available in the functions menu, and I'll show it to you in just a second. So you can add it to your stack and then call it and use it. So let's tackle it in steps, and I'll just keep adding on to this design. So if you're following along, you don't have to start over, but obviously you can if you want to. It's a very quick start. You add a shape and you add the touch listener to it. Okay, so let's head to the functions palette, and I've named the button to get the bounding box get boundary box. So if you click it and watch the stack, you'll see we get this function added, get boundary box. I'm going to move it to the top just because that's normally where I move app level variables and functions. Just from a stack organization standpoint, I always know where to look, in the stack. So let's peek at our code. Okay, so here's get boundary box, and I think it's essentially the same exact code as is in the keynote, but here it is. It's ready to use. Importantly, I haven't used it. Some people get confused and think you're done. You added the stack, so now we've got the boundary box and we're all good, and that's not the case. Pressing this button in Draw in a Code gives you the function to use, but as the programmer, you still have to use it. Even though we've supplied the function, we've added the function to our stack, we have not used it. So you use a function by calling it, and this function returns data. So the way we'll call it is we'll write a statement that captures the return data and stores it in some way that's useful to us. So this is one of these really kind of neat, I think, features of Lua is we can just add new attributes to a table by doing it. So what I'm doing here is adding a bounds attribute, it's a table, to object 1. Object 1 is the star. So the line of code is object1.bounds equals get boundary box object 1. So I'm sending object 1 to the function get boundary box. Get boundary box will do all of this math and then return the result, which gets stored here into object1.bounds. All right, so I need to call it. I'll call it in my stack using a snippet. So I'm going to head over to snippets palette here at the bottom and say new snippet. I want to add this bounding box to my object 1 because that's the object in the stack that I want to limit, that I want to fence, that I want to bound in. So I'm going to call it bounds just because that makes sense. I'm going to call the function that I've added, which is get boundary box, and I'm going to pass it the object 1. And I'm also going to name the snippet set up boundary for object 1. That way my stack is easy to read. In terms of location in the stack, you might be wondering, well, where do I put it, in the stack? Well, you'll want to put it in the stack after you've created object 1. If you try to call a line of code that uses object 1 before you've created object 1, then you'll get that nil exception trying to reference a nil value error you'll see at the console. So it doesn't entirely matter where you do this in your stack, at least for this simple stack, but it does have to be below wherever you set up object 1. All right, so we have now created the bounds, but we're not done because we're not enforcing them. We're not using it. When you call the function that generates this bounding data, so it's created the data for the fence, but it hasn't created a fence. For the data to do anything, we're going to have to implement some if-then logic in our code that uses the fence. Before we get to the logic of how to use the fence to actually bound the star, let's see the fence. So that's a little bit of work just because we're going to have to create a display object. If we want to draw a rectangle, which is all we're doing here, if we want to draw this rectangle, we'll need to create a rectangle, and then we'll need to set its width and its height. And we don't have its width and height in the bounds data directly. In the bounds data, we have the left and the right edges, but not the width, and the top and the bottom edges, but not the height. So we have to calculate. We have to do a little bit of math to calculate the data needed to create a rectangle display object in Solar 2D. So this is the code here, but I say all that just because it probably seems more involved than you might expect. We've been creating rectangles from almost the second week of class maybe, and now all of a sudden there's all this math here. And so we could type it in, or if you have the Keynote PDF downloaded, you should be able to go to that page in the Keynote. It's slide 10, I should say, and grab that. Okay, so this is the code I'm talking about. Again, I grabbed it out of the Keynote. I want to put it in my app so I can see that fence. Since I already have a snippet and I need to have the bounds set up before I can do this bit of code, I'm just going to add to this snippet because the snippet's just got one line of code in it. And since this has to do with viewing the boundary we just set up, it makes sense to put it in here. I don't want to do that. Again, I've called the rectangle object 7, which is okay, except in a real app, I would probably call this something more like fence or bounds or boundary box or something like that. And sorry, kitty. What? I don't know. All right. Okay. Well, let's see it. If I've got this in right, now when I save it, we should see. All right. So that argument number 1, what did I do? I think I forgot to set up display constants, but let me double check. So sorry. Just to keep the amount of code to a minimum, I have this habit I picked up when I was learning this, and I coded everything by hand, which is to set up display variables because you use them so much. So 2 of the display variables that you use a ton are the X and Y location of the center of the device display. So you can get that programmatically by typing them in as display.contentCenterX and display.contentCenterY. Or you can use this display constants button inside of snippets. If you hit that, you'll get this display constants display object and move it up to the top. And if we peek at it, what you'll see is it defines CX, CY, and also content width and content height. So it's useful to do if you're going to be doing any hand coding which involves placing and moving stuff around the screen by hand. You do not have to use them. You can type out display.contentCenterX and display.contentCenterY, without needing this little bit of code. In any event, that should take care of the complaint. So our error went away, and we should now see the red box. If you take a second now and just play around, you'll see that it doesn't do anything, right? All we've done is draw the red box. And there is a bit of a gap because the content area in drawn to code is set up for the smaller iPhone screen. This is a taller iPhone that I'm using in the simulator, so we've got a bit of a gap at the top and the bottom. But let's get this thing working before we even worry about that. I don't want the star to be able to get out of the box. And right now, it can get out of the box. So, and I even say down here, I just wasn't reading my own slide. In drawn to code, add the display content snippet for CX and CY. So if I fully read my own slide, I wouldn't have had that very long moment of confusion. The advanced note talks about something like this, is that there's additional stuff that you'll need to do. And I've provided you an example of using the content area or using the actual device fence. And so in the resource downloads, there's a variation of this that shows you kind of how to fix it, and also lets you toggle it on and off so that you can see the difference. I'm going to skip over that. Okay, enforcing the fence. Now that we have the fence, we want to use it. And we're going to use it. This is the code. We're going to add 2 if-then statements to limit where we can move the display shape. And here's where having left, right, top, and bottom are handy. I do not have this built into drawn to code to write, so you've got to either type it in or cut and paste it. So I want to copy this entire chunk out of my keynote and paste it into the drag event handler. So I'm going to jump over and do that again. I want this whole chunk of code. I'm going to copy it, head back over to drawn to code, and I'm going to jump now into this snippet object 3, which is the touch handler for the star. So this is all code is default. Drawn to code writes for you, and we want to edit right in the middle. If you're following along, you don't have to do the indentation. Obviously, you could just save it and see it working, but on my screen, I want this to look good for you. So essentially, the way I think of it is I'm proposing a new X and Y location. The new proposed XY location for object 1 I've called X and Y, and now I'm going to check and see, is it a good X and Y location? If X is good, then I'll set X, and if Y is good, then I'll set Y. So let me see, dragging, and hey, hopefully if you're following along, what you'll see is your star just kind of bumps right up against the edge, but won't go over. So our fence works. All right, so we have essentially just done step-by-step activity 2. So if you have followed along, you've completed activity 2. So yeah, we've hit that magic time in the presentation where you have the ability, get a bonus galleon. So you've learned dragging, and you've learned the use of the boundary box to fence in or limit the ability to drag. So we will move on to more fun stuff on Thursday.